You know, we're all swimming in an ocean of data. But if you ever stop to think about how all of that data actually moves, well, behind the scenes at a ton of the world's biggest companies, there's a technology that acts like a digital central nervous system. It's called Apache Kafka, and it's the secret sauce that lets real-time data flow reliably at a mind-boggling scale. Okay, let's dive in and really get our heads around how this whole thing works. So here's the game plan. We're going to start with the problem that Kafka was built to solve, what I like to call the data traffic jam. Then we'll get into its really big core idea. We'll meet the three key players that make it all happen, walk through a real-world example of an order, understand the promises Kafka makes about delivering your data, and then we'll zoom out and see its huge role in the modern tech world. All right, so first things first, why does Kafka even exist? Well, it all started with a problem that pretty much every single growing company runs into, the data traffic jam.
I mean, just think about any app you use. Every single thing you do, a click, a search, an order you place, a photo you like, all of it creates a little piece of data, an event. And that event needs to be recorded and probably acted on by a whole bunch of different systems.
Now, in the old days, you'd just connect systems directly. The website tells the inventory system about a sale. The inventory system tells the shipping system. The website also has to tell the analytics system. Pretty soon, you end up with this, a tangled, brittle mess that engineers call spaghetti architecture. And yeah, it's as messy as it sounds. Trying to add one new service is a total nightmare because you have to connect it to everything else. It doesn't scale.
So, that leads us to the billion-dollar question, right? How do you untangle this mess? How do companies handle this constant high-speed flow of data from thousands of sources to thousands of destinations all at the same time? The answer is actually kind of beautiful in its simplicity. Instead of connecting everything to everything else, what if all the systems just wrote to and read from a single universal logbook? That, right there, is Kafka's big idea. At the very heart of Kafka is something called a topic. You can just think of a topic as a category in that logbook, like user clicks, orders, or payments. When something happens, an application just adds a new message to the end of the log for that topic. And it's append only. You just add new stuff. You never go back and change what's already there. This makes it incredibly fast and durable, kind of like a permanent record of everything that's ever happened.
Okay, but a single log for something popular like orders would get bogged down pretty fast. And this is where Kafka's genius really kicks in. It splits a single topic into multiple parallel logs called partitions. This is the secret to Kafka's incredible speed. It can read and write to all these partitions at the exact same time.
And to keep track of everything, each message inside a partition gets its own unique sequential ID number. It's called an offset. Just think of it like a permanent page number in our logbook. This little number is so important because it guarantees that messages stay in order within that one partition, and it lets every application remember exactly where it left off reading. Okay, so we've got this structure of topics, partitions, and offsets. But who's actually doing the work of writing to and reading from this thing? Well, let's meet the three key players. First up, we have the producer. This is any application that writes data to a Kafka topic. When a producer wants to send a message, it has to convert it into a stream of bytes, the language the computers speak. This process is called serialization. It's basically how you take something complex, like a customer order, and package it up so it can fly across the network to Kafka. So where does that data go? It goes to a broker. A broker is just a Kafka server. Its job is to grab messages from producers and store them safely. But, and this is super important, you never run just one broker. You run a whole group of them called a cluster. This is how Kafka stays so reliable. Every partition gets copied or replicated across several brokers. One broker is the leader. It handles the live reads and writes. And the others are followers, just keeping their copies perfectly in sync, ready to take over in a split second if the leader fails.
And finally, we have the consumer. This is any application that reads data from a Kafka topic. Now, a single consumer could try to read from all the partitions by itself, but that's slow. The real power comes from consumer groups. A consumer group is basically a team of readers. They all work together. And Kafka is smart. It automatically makes sure that each partition is only being read by one consumer on the team at a time. This is how you get that massive parallel processing. If you have 10 partitions, you can have a team of up to 10 consumers, all chugging away at once.
So, we've got the theory down. Let's make this way more concrete. Let's trace the journey of a single e-commerce order as it flows through a Kafka pipeline.
Okay, so follow the data with me. Step 1. You hit Buy Now. The website acts as a producer and sends a new order message to the orders topic. Step 2. The Kafka cluster of brokers gets that message, stores it, and immediately makes copies for safety. Step 3. Now the magic happens. We've got multiple consumer groups all listening to that orders topic. Step 4. Each group does its own job, totally independent and in parallel. The shipping services consumer group sees the order and starts preparing the delivery. At the very same time, the inventory services consumer group sees it and updates the stock count. And the analytics consumer group sees it and adds the sale to a real-time dashboard. The coolest part? None of these services know or care about each other. They only care about Kafka.
This real-time, untangled setup is incredibly powerful, but it's pretty useless if messages get lost along the way. So, this is a crucial question. How does Kafka guarantee that data is delivered reliably?
Well, Kafka offers a few different levels of guarantees, what we call semantics. There's at most once, it's fast, but it's risky. Messages can get lost. Then you have at least once, which is the default. It ensures messages are never lost, but in some rare failure cases, they might get delivered twice. And then there's the gold standard, exactly once. This means every message is delivered one time and one time only. No losses and no duplicates.
And how do you get this gold standard? It's not magic, it's just really careful configuration. As you can see from the docs, developers can flip a few switches. By enabling something called idempotence, which is just a fancy way of saying if you see the same message twice, just ignore the duplicate. And setting this AX equals all property, you can guarantee exactly once delivery. That AX equals all bit is so important. It tells the producer, hey, wait for confirmation from the leader and all of its followers before you say this job is done. It's the ultimate promise of data safety.
So, when you put all of this together, the scalability, the way it untangles complex systems, the rock-solid reliability, you really start to see why Kafka has become the new data backbone for so many companies.
It truly acts like this central data nervous system. It lets all your applications evolve on their own without breaking each other. It makes true real-time streaming analytics possible. It's the fire hose that fills up massive data lakes and warehouses. And more, it's the technology feeding live, fresh-off-the-press data into machine learning and AI models, making them smarter and more responsive with every passing second.
Ultimately, Kafka totally changes how we think about data. It shifts it from being something that's stored away and queried later to something that is alive, that is flowing in real time. And that leaves us with a really fascinating question to think about. If data is the new oil, what amazing things can we build when it flows instantly, everywhere, to anyone and anything that needs it?